Greetings, parents of the grade 6, 7 class of 2025. I know you've sent some very valuable questions and suggestions to me via Christine, and I thought I'd um, make a presentation in response to them in anticipation of a meeting so that the meeting can be most productive. So I don't have to have only present some ideas over there. So welcome to my kitchen, and here are some responses. Let's just bring them up. So I know it's quite clear that we do things quite differently in maths at Kairos, and these differences are grounded in very solid um, education theory and maths education theory. So I hope I can summarize some of these questions and at the same time respond to your questions, which I understand if I've condensed them to 4 points. The question of our maths curriculum at Kairos in general, how we differentiate between the sixes and sevens in this particular class, the question of transitioning to high school in a smooth and most effective way as possible, and the question of extra math support that might be needed, either by me or others, for your students, for your children, for my students. So just I thought I'd start with some fun, some cartoons. I love this cartoon. Mr. Osborne, may I be excused? My brain is full. Which speaks so much to the emotional and social kind of reality of a maths classroom. In general, there often is some resistance to learning maths. Maths is not an automatic, intrinsic, natural ability unless you somehow have acquired it over time, but it's very common that children resist learning maths. Maths itself is a strange animal because it teaches logic and logical thinking and a variety of mathematical mental cognitive skills in a way that sometimes seems arbitrary and contrived. Um, for instance, aren't there enough problems in the world already? And I think there's a question of problems in the actual world which children are naturally engaged and interested in. So therefore, why should we be considering maths problems? And then the actual syntax of maths is also can be confusing. So in algebra, the challenge to find x is is wonderfully played on here. Um, Similarly, the silly maths word sums are played on here. How I see maths word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. And I think that sometimes children will respond to maths questions as if they are absolutely irrelevant, ludicrous, illogical, and nonsense. This is quite interesting from a Kairos point of view, and I think that this is very important from an educational perspective because maths itself is often not taught in schools. Maths taught in schools is often not maths in reality. Maths in schools is a school's maths, and sometimes it's separate from the rest of mathematics. So when you learn maths at school, you're not really often learning mathematical thinking. So here, should we put down what we think is right, miss, or what we think you think is right? And it's very similar to coding, for instance, which is not really teaching software development or software programming, but just to follow the numbers. So in maths, learn what I say, a teacher might ask, remember how to do this method. Here's a trick, and repeat it and in the test many times, and you'll do great in your test, which is not what maths is. So, what maths according to a very seminal paper by this Professor Kilpatrick, um, is five different things. Maths is conceptual, the skills required for achieving conceptual understanding, strategic competence of solving problems, and similar in the tasks of solving problems to have the skill of adaptive reasoning, to be able to be flexible and pick up a logical skill in one area and reapply it to another area, and be able to be flexible with one's thinking, so one can respond to the challenges of the particular context. And then these last two are more familiar to most school maths contexts. One is fluency, to just be fluent, often quick in the language of maths, and in this case, often school maths. So one recognizes a sum that's presented in school maths language, and one performs the procedure that's required, and the result is, the procedure is usually can only be one method. One must be fluent in it, one must produce the right answer, and then one gets a tick and a good mark at the end. So procedural fluency is a part of maths, an important part, but it is only 1 out of 5. And unfortunately, it is the one that's very strongly emphasized in most maths school classrooms worldwide, and to the neglect of these other important skills. And then productive disposition is an emotional attitude towards the maths task, not simply enjoyment of the maths, but also a sense of confidence that one can be productive in tackling a task. So I just want to contrast, this is a different theorist, this different professor from Stanford, Jo Boaler, and she talks about old maths and new maths, and a mathematical mindset. So the old maths is to teach automatic recall, basic facts of numbers, usually to the neglect of patterns, and then to be able to remember something, perform it as one has practiced, and to repeat. So these three things: remember, perform, and repeat, again and again and again. And you do that for 12 years, and you might, in fact, get a distinction in maths. But whether or not you have maths, whether you have mathematical thinking, is questionable. And usually, so maths is a particularly unusual subject, that even if you remember the skills of primary school and early high school, there is a danger that you will not be able to achieve a distinction unless you do acquire some degree of a mathematical mindset, which are these more advanced cognitive skills, to be able to observe and question and explore mathematical concepts, which are sometimes numbers, sometimes patterns, and sometimes sequences. So the numbers and the patterns is very, very important. To be able to look at something and explain why something is happening, and explain how something happens, and in fact sometimes explain why something is not. So why it is true or why it's not true. And so to investigate patterns and give reasons to justify one's statements, not just to make a statement in mathematics, but to give a good reason that justifies the statement. And then to connect the facts between one fact and another, and to spot one phenomenon in maths and notice it in another area, and potentially there's even wonderful connections between language and maths. And there's ways of analyzing a sentence in English and look at the mathematical logic within the sentence. Let's say with the conjunction and and the conjunction or is really useful in facts that mathematical patterns that one can notice when something and something else is true, or something is true or something else is true. So there's connections between across contexts, and most, in this case, most importantly, within different mathematical contexts. And so therefore, in this last one, to apply learning in one area and into another area. So I think it's really important that we in this grade 6 and 7 class, having acquired something of the basics of maths up to now, I really feel it's valuable and important to be learning these skills of a mathematical mindset, which is generally and usually neglected in a maths class, right through from primary school to matric in conventional schools. And the mathematical mindset is able to prepare a student to apply one's mind in different contexts, in different unfamiliar contexts. So when one approaches a new area of maths, let's say trigonometry in the future, or calculus, or some unfamiliar challenge and familiar task, one is able to acquire, one has acquired the confidence and the ability to unpack, analyze the context, and come to some kind of answer that is required, even in an unfamiliar area of maths. So there's also just this commentary from Dr. Seuss of the school system, which I just want to introduce you. Just outside maths itself, there is the idea of the school system. And the school system is important, and at Kairos, we've always balanced the need that that parents and children still have a reasonable expectation of this green star that parents are paying for in this machine of school. So this is the Sylvester, what's it? Sylvester McMonkey McBean's Starbelly Sneetch machine. And it is a game, it is arbitrary, it is contrived, and some of maths is also arbitrary. And the whole of much of school is also arbitrary, and yet coming out with the mainstream qualification is valuable, especially in a social context, and in a sense that the children and parents feel that they are doing what they need to do to pass through this machine. And I think I understand there's sometimes some anxiety that children are doubting sometimes whether or not they're getting what they need to get. So last year I had a comment in the grade 6, 7 class, why aren't we doing the area of a triangle, half base times height? Even though the majority of children who learn half base times height will have no idea why an area of a triangle is half base times height. They won't recognize the fact that it's half area of a rectangle. And in Kairos, in 6 and 7 class, we really emphasize this the sense of why. Why is everything? Why does something? Why do you do this in maths? What is the point when you're dividing a fraction by another fraction? Why do you tip and times? Not simply, let's just do tip and times. Trust me, you must do tip and times, it'll work. Because when you get to the next level of some kind of algebraic fraction, there might not be an understanding of what the tip and times does, and therefore at a later date, a tip and times method, a mindless method of maths, sets the child up for future failure because the understanding hasn't been prepared in advance.